Good morning.
Good morning.
How was your weekend?
I would say fairly basic other than house cleaning.
Yeah, we did some house cleaning, but did you do anything fun like ride bike or anything?
My brother is like, hey, we're gonna go run 2 laps around Pleasant View just on a whim.
Oh, okay. And how was that?
I was doing good through the first one, then about a quarter of the way through the second one, I'm like, why did I agree to the second part here?
Is he younger than you?
He's 3 years older.
Oh, okay. So what does he do besides stay at home now?
He still works actually. He's at Nahan Printing.
Oh, okay. I thought maybe you're not a motorcycle fanatic or anything, are you?
No.
Yeah, my son and I went for a bike ride yesterday. And he's 26. And basically we were biking about 18 to 20 miles per hour for about 32 miles, and I was dead afterwards because I that's way too fast for me. So but it was a nice day, nice weekend. It's gonna be a nice day today.
Yeah.
All right, good morning, everybody. I got some things I'm gonna tell you. The first thing, did everybody get my message that I sent out? Kind of what I was covering this week. Okay. Um, and so let's see if I can find what I'm looking for. No, I didn't want to do that. Here it is. So you should be getting something from AP, and you want to make sure you review your contact information. This is what they're sending to me. Um, they are AP is communicating through email. And so what that means to you is you want to make sure that you're able to log, excuse me? Okay. You want to make sure that you can log in to my AP, and you want to make sure you know the email address in which they're contacting you and the cell phone number you asked the College Board to use. You can change how you contact them if you choose to. 2 days before each of your exams, you will receive an email with a personalized e-ticket that will include your 8-character APID code. If you do not receive the email, you'll be able to access your e-ticket directly through my AP. Does that make any sense to you at all? Okay. I also have a number of directions for me. One of the things I sent out is I went to a link called, so AP has been offering classes. And what I did is I went to that link this morning, and they've broken down everything by topic. And the sessions are about 50 minutes. But what's nice about YouTube is you can skip the stuff you don't want to listen to and pick and choose what you do. Okay, that's what's kind of cool. So if you, let's say you're struggling with continuity, something I'm going to talk about today, you can go and they'll have a topic called continuity, and then you could watch the video. And so I sent you that link today. Did anybody see that? Okay, so take a look at that. I think the people presenting are very, very good, but again, the length is about 50 some minutes, and so but it is broken down by topic, and that's what I really like. So if you're okay with sketching slope fields, you don't have to watch that one, but there is one like, okay, sketching slope fields, and they'll give you some information, and you can use, oh, you know, maybe there's enough information that you just need a little reminder. Okay, does that make sense to everybody? Again, and some people are starting to do it. If you need to schedule an appointment with me, feel free to do that. And so that's other information. Any questions about that? As I get information, I'll pass that along, but make sure you're watching your email from AP. Okay? All right. The next thing I want to do is turn this thing on. We'll see how this works. And I do want to talk about piecewise graphs, continuity, and differentiability. And so I kind of crafted something up today, and we'll see how it works. All right, let's see if I can share something with you. So do you see my hand? Yes,
Yes.
sir. Yes?
Yes.
Okay. Because I never know. I mean, I believe you see everything, and I gotta get that out of the way. I find that. All right, so here's the problem. Oh, before I go on, I gave you another free response number 4. And I threw that out as an assignment, I think a quiz. And it's not due till next Tuesday at midnight. Okay? And what it is, there's 2 questions. And the first question takes 25 minutes, and the second question takes 15 minutes. And you can do them how you want. You can do them both at the same time, or you can do them separate times. I don't care. What I think you should do, and I'm strongly suggesting, is give yourself 25 minutes, and then you will have 5 minutes to upload it and send that to me. So that's practice of what you'll be doing on May 12th. Does that make sense? So as soon as you're done with it, when your 25 minutes are up, however you've been uploading and sending it, make sure you're sending it to me within 5 minutes of completion. Then if you want to do the 15-minute one, which is next, that's up to you. If you want to wait a day and do it. But again, when you finish that, give yourself 5 minutes to upload it and send it to me. All right. Okay, so here's my problem. I'm going to have a piecewise curve. And it's f of x is equal to a negative x squared. Oops, I didn't make this bracket good enough. I'll start over again. I don't like it. F of x equals, I need a bigger bracket. And it's going to be a negative x squared plus 3 when x is less than or equal to 1. And then it's 3 minus the square root of x when x is greater than 1. So the first thing I want to do is, how do I demonstrate continuity? All right, I gotta let somebody in here. How do I do that? How do I get to participants? Right here. So continuity. All right, showing continuity, you have to show that the limit of this function is equal to f of x. So the question is it continuous continuity at x equals 1? So I have to first show that f of x equals 1 exists. And so when I put 1 in for here, it's going to, 1 is less than or equal to 1. It doesn't fit here, fits here. And when I plug in 1, I get 2. So that's the first thing I need to do. So there's a value at 1, and that value is 2. There is a y value there. The next thing I have to show is that y value is the same as the limit. Well, because I have a piecewise graph and part of the domain goes to the left and part of the domain goes to the right, I have to examine the left and right side limits. So what I'm going to do is I'm going to take the limit as x approaches 1 from the left, and I'm going to have to use this function. And it's as it's approaching this. Well, if I can substitute, which I can in here without worrying about division by 0, I go ahead and do that. And I get 2. And now I'm going to take the limit as x approaches 1 from the right. Again, it's what it's approaching. I know that x can't be 1 because I'm not allowed, but what is it approaching? And I can find that by plugging 1 in for x. I get 2 here. So that means as the value is approaching 1 from the right side, like 1.1, 1.01, 1.000001, it's getting closer and closer to 2. So that means that the limit as x approaches 1 of f of x is equal to 2. That limit exists. Why? Because these two are equal to each other. So if I'm asked to justify, I can say the limit as x approaches 1 of a negative x squared plus 3 equals the limit, excuse me, I wanted left here, not right. Sorry about that. The limit as x approaches 1 from the right of 3 minus the square root of x, they're the same. So this limit exists. And the limit as x approaches 1 of f of x is equal to f of 1. Therefore, f is continuous at x equals 1 because this is true. that there's a y value and the limit of those y values. That's what you have to show me. And a lot of people aren't showing me that and are really sloppy in their limit. You're not allowed to have this. The limit of what? And so some of that's got to tighten up. Now, let's look at differentiability. That means, can I take a derivative at 1? Well, I'm going to find the derivative of this piecewise graph. And that derivative, so if you take a look up here, I have a negative x squared plus 3. If I take the derivative of that, I get a negative 2x for x is less than or equal to 1. If I take the derivative of this, well, what is this? This is 3 minus x to the 1/2 power. If I take the derivative, 3 becomes 0. I'll have a negative 1/2 x to the negative 1/2, which is this. Negative 1 over 2 times the square root of x. And that's for x greater than or equal to 1. So now again, I'm going to take the limit. I'm going to approach x of these derivatives. Approach 1 from the left. And I do that limit by substitution if I can. The only thing I don't have to worry about, the only time it says I can't substitute is if I have division by 0. And I don't have division by 0, so I get a negative 2 here. Now if I take the limit as x approaches 1 from the right, and I'm going to have a negative 1 over 2 square root of x. And again, I don't have to worry about division by 0. I can plug 1 in here and I get a negative 1/2. They're not equal. So I can't take the derivative at x equals 1. They're not differentiable at x equals 1. Because these are, so the limit as x approaches 1 of the derivative does not exist. Now, why doesn't it exist? Let's take a look at a graph, and I think I got a graph here. So I'm going to stop sharing this and see if I can get you the graph. Do I need to let people catch up that are writing this down? Okay. Okay, let's see if I can share. Okay, let's not share that. Let's go over here. Let's go to here. Let's go over here. Okay, can I share this now? Yeah, awesome. Do you see this? Do you see this, Desmos?
No.
No? Okay. Okay, let's try this. Oh, it's not going to let me to share. God, this is a finicky thing. Let me try one more time. If not, I got something else to show you. So that's. Do you see it now? All right, super. Eventually I'll overcome this. So if you take a look at this, here's where, oops, let me make this a little bit bigger. Here's where x equals 1. Here, there, you can see it's continuous. Here's the parabola, and then here's the square root, okay? Well, there's a sharp point there, correct? You could see that the tangent lines would be on the outside, and the tangent lines here would be in the inside, and we got a sharp point. So graphically, it should be, hey, it's not differentiable there because there's a sharp point there. All right. Next problem I wanted to share with you is this one. Landry, does it seem like I'm going too fast?
No, I think you're going at a good speed.
Okay. It seems like I'm going like 90 miles an hour, so I'm sorry if I am. Okay, can you see this?
Yes.
Okay, and the reason I chose this, and this is in your folder, it's 2016. You can see all the problems I'm going to be talking about them. I'm not going to go in order 1, 2, 3, 4, 5, 6. I'm going to go in order on the ones that I think, from what I've seen, we need the most work to discuss. And the reason I picked this is because, first of all, there's this graph. Secondly, it defines g of x as an integral with a variable in it. Specifically, we call g of x an accumulative variable, cumulative function, because it's an integral that gains more and more area underneath the curve as x keeps getting bigger than 2. Okay, so it starts at 2 and has a different direction. And then we have questions about relative min, relative max, neither at x equals 10. So there's the figure. And I liked it because there's no calculator allowed, and you're probably you can use a calculator on the AP exam, but you don't need to use a calculator. And so the question is, does G have a relative minimum, maximum, or neither at x equals 10? Does G have that? So, how do you determine? Now, as I approach this, when I look at a question, I have to make a decision on what direction I'm going to go. Am I going to take a derivative? Are they talking about derivatives, or are they presenting me a derivative problem, or are they presenting me an integration problem? Does that kind of make sense when I say that? Are my steps to integrate and everything related to it, or are my steps to take the derivative and everything related to that? So Landry, the words relative minimum, relative maximum, or neither indicate what to you?
They indicate probably integration.
Integration, okay. Why did you feel that?
I feel that because taking the derivative wouldn't make any sense in this situation.
Okay. So is G a derivative?
No.
No. Okay. So it's a function, correct? It's kind of a crazy looking function, but it's a function. And anytime we want to know something about a function and we talk about minimums and maximums, aren't those turning around points?
Yes.
Okay. And at turning around points, aren't the slopes of the tangent lines equal to 0?
Yes.
And so when I say slopes of a tangent line, what does that indicate?
Derivative.
Okay. So what I'm going to do is right here, here's g of x, okay? And I'm going to take the derivative of g of x, and the reason why is I'm going to look for horizontal tangent lines. I'm going to look for where the derivative equals a 0. Now, taking the derivative of this side is pretty easy. Taking the derivative of this side, you have to remember something called the fundamental theorem of calculus, part 2. What I sometimes wrote on people's notes, FTC part 2, which says if you take the derivative of an integral, you're basically going to get this function. With what? And I'll take a response from anybody.
F of x.
F of x. And you're really multiplying that by 1, but because that's the derivative of x, correct? So they're telling you that this graph right here is the derivative of g. So let's take a look, and we want to know where f of x equals 0. Specifically, f of 10. Does f of 10 equal 0? Well, if I look here at 10, is that 0? It is. So it's a critical number. X equals 10 is a critical number. Now, is it a relative minimum or maximum? The slope of the tangent line is 0 because it's 0 right here. But is it a relative min or max?
Would it be no?
relative?
Oh, somebody said something.
Would it be no because it doesn't cross over the x-axis?
Right. Is a critical number, but not a relative min or max, since it, and can I, was Caitlin, was that you?
Yeah, it was.
Okay, can I say this doesn't change signs?
Yeah.
I think you'd probably can get by that doesn't cross the x-axis. But I think they're looking at it some way not changing from positive, negative, or negative to positive. Okay. Very good. So really, the only potential ones are a -2 and 6. Would everybody agree with that? Caitlin, would you agree with that?
Yeah.
Okay. Now, Caitlin, 6, relative min or max?
Would it be a relative max as it goes from positive to negative?
Yes, exactly. Okay. All right, good. All right, how are we doing on time? I am going to try B, okay? So B is, now we've established that this graph is a derivative, correct? It's a derivative of G. Does the graph of G, which we don't see up here because we see the graph of F, does the graph of G have an inflection point at x equals 4? Here's x equals 4. Is there an inflection point there? Austin, what do you think?
I'm not really sure.
Okay. How do you know when you have inflection points?
Is it? I feel like I have an idea in my head. I'm just gonna pull it out.
Okay. Okay. Sophia, are you there? I think she said no. It's when the derivative goes from increasing to decreasing or from decreasing to increasing. So this is an inflection point. 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 So the answer would be yes, because the derivative, because f went from increasing to decreasing. Okay. All righty. I'm going to come back to that tomorrow and finish up on this problem and talk about some other things that I think I need to talk about. Again, if you have any particular questions about something you come across, feel free to ask them. I'll either get back to you right away or take some time or talk about them the next day, but I will talk about it because I want to make sure you know. Okay. Again, I'd encourage you to take a look at the videos if you need any type of review. But again, your guys' schedule is pretty busy, so I don't want to overload you either, but I'm just trying to get you prepared. Okay? All right. You guys have a great day. We'll see you tomorrow.